Okay, welcome to week number 6. So today we are going to discuss the transport layer. And before that, just to recap what we have done up till now from week 1 to week 5. So first of all, just to recap it quickly what we have done last time. Can you please come there? Move forward. There. So first of all, with the network layer which we have done last time, we discussed that network layer is all about IP addressing and routing. And in network layer, all communication is done on host to host. Whereas for data link layer, all communication is done for hop to hop. Okay? Whereas network layer is host to host. Each network on the internet has a unique network ID. Remember that last time when we discussed with the different network, they have their router and they have their ID. And by using a separate mask, we are able to find it out that okay, this is for this network, and then there is a network of routers, then network of another network. A network ID is a similar thing like the ID of, let's say, a Sydney. 02 is the network code of, if you want to make a landline call in Sydney, you need to dial 02 first. In Melbourne, you need to dial 03 first, or country codes. So they are like a network IDs. So in the similar way, in the field of networking, they have network IDs of each network as well. And we know that with the IP addresses, they are divided into two parts: network part and node part. Network part are one which are common for everyone. Node parts are one which are the nodes, the computers which we have, and we have different IP addresses for them in the network. Another definition of subnet mask, that's why we use subnet mask to see how many number of IP address we can create in a network. And another name of subnet mask is CIDR. That's another way of explaining the subnet mask. And we had already a lot of discussion on subnet mask. And that's also part of your assignment as well. And with your computer, they always work with the DHCP server to get the IP settings. And then we learned about two different versions: IPv4, IPv6. IPv4 has 32-bit, IPv6 has 128 bits. And for DNS, domain name servers, job is to translate domains into IP addresses. And then in the last, we have seen the network address translation. And that is all about to access or to give the access to the private addresses to the internet access. You remember that in the Linux, when we are doing the lab, in this initially you are getting some errors of network error. And we went to the network settings and then click the NAT address. So what was that? That is actually this thing which actually remembers that there are two type of addresses: public addresses and private addresses. You know the difference between public and private? Public addresses are which one? Example? Yeah, so for example, yeah, Facebook, Federation, Moodle, Google, they are all public, which can be accessible from anywhere in the world. What about the private ones? Yeah, in the home networks, in the organization inside network, they are private. So that's why on a Linux, when we are going to uh, assign a network, because that is in a private network, so we need to click a NAT. NAT's job is to give that private computer address of public address, so it can communicate in a public domain and can get access to the network. Otherwise, it's not possible. So remember that whenever in a public domain you will go with the private label, public domain never accepts you. Okay, that's why it's important to use the net when you want to. And it actually, what it does is it takes the private IP address and translates in a way that it looks public IP address, so that you can get internet access. And we know that with the IP packets, routers are concerned with sending packet toward their destination. For example, from one router to another router to next router, and in that way it reaches at the destination. A review of what we know up till now, because it's important to understand what we learned, because based on that today's lecture is really important based on that. So if we look toward the data link layer, what was the job of a data link layer? What is the other name of data link layer? Anyone? What data link layer is about? Hmm? But what else? There is another thing as well which we discussed. What else? Data link layer. Hmm? Very important point about data link layer. What is the other name of data link layer? Any idea? You have notes, everything. Look into it. Quickly go to your notes. Please remember that in your learning, it's always important to be more interactive. Try to give the answers, because if your network interface, yes, network interface card, NIC card, hop to hop. So data link layer is all about hop to hop. Hop mean my computer to next computer, and it works with the MAC addresses. With the MAC addresses. So in the data link layer, what we have seen is if both computers are from the same network, then that message will not go outside. It will just deliver there. How we know that? By using the network IDs differences. If the network ID is same, so it means that that packet is for the same network. If the network ID is different, then it means that that packet is not for that. It's sent to the router, and router's job is to send to the other routers where it has to go. So you can see that two choices on a data link layer are deliver to intended destination is in your local delivery or a remote delivery. Okay, but in the remember that data link layer is all about Ethernet, NIC card, hop to hop, MAC address. Okay, whereas on network layer, it was the network layer main job was host to host communication, to end two computers communication. And in network layer, we are more discussing the IP addresses, not MAC only, IP addresses. And in network layer, we are discussing about the routing protocols used by the routers. We are not going to depth of that, but mainly we know that when on internet layer, network layer, we are discussing our packet is definitely going outside my network. Whenever it's my own network, then I'm always play with only data link layer. Network layer never comes to play its part. But as soon as I jump from my own network to the bigger network, public network, then the job of network layer comes, and we are sending the packets over the internet. And then routers jobs are that there are some registers, they maintain it, what's the packets coming into that routers, what it is left, they all have that data. So based on that, they are trying to take our message to the destination host computer. And therefore each IP address contains network ID of each packet. Subnet mask is there to compute network ID. So the question now comes is, which is really important for today's lesson, to where we have to now move forward. Have a look what is those two questions are about. how much you have understand it, or I would say that 50% of the knowledge is all about just understanding the question first. So first part of this one, does it make sense to you? Please, I'm giving you a few seconds. Read it through and see, does it make sense to you? Any idea? Anyone want to explain that question? I'm not asking about to give the answer, just to tell me what is the problem we have now to address in future. Whatsoever we have learned about network layer, about data link layer, application layer, we have learned 3 layers. Okay, still 2 more layers left. But what question you have understand from this part? Any idea? It's okay, you can make mistakes, still you can give answer. It's not about feeling some shame on that or feeling that scaredness inside you. Mainly it's all about, you need to be interactive in your practical life. You need to be more talkative, convince other people with your talk. And if you are not learning that thing in universities, colleges, then sorry for that. Then it's okay to go and YouTube and learn those things as well. Still it makes sense. So that's why I'll always try to encourage you to talk, to take participation in your those things. It helps you to improve yourself with your shyness that I need to remove from you over a period of time then. So what do you think? Any idea? What is that question is about? What you didn't understand from that question? You understand network traffic or not? So okay. So okay, first question is network traffic. That's fine. Okay, anyone else understand the full question or having some
How does the
trouble?
network traffic will locate the destination?
By using the IP address, DNS and socket
Correct, correct.
Yeah, so up till now we know that, like when we are going to browse anything, so when it reaches at the receiving end, so it is by network layer, host to host. Now assume that our packet, our data is reached on the destination. So what is the next question here is? Correct destination? Application. What is application mean here is? What is application mean here is?
program, program,
What program? Yeah, tell me.
kind of an app or like
Yeah, what's the app we are using on our laptop? What are the apps we use? Hmm? Say loudly. It's okay. Make browser. What else? What WhatsApp, Skype, Mozilla.
Websites.
Okay, Teams. So anything which needs connectivity of internet. That's your app. So on the destination host. So on the computer where the data is going. So what the problem we are getting here is, because the thing is that if you are not sure about what is the problem, you don't know what you are learning then. Make sense? So if you know the problem, believe me, your level of understanding will be so high that you don't need to remember them. Because like whenever we have a real problem in our life, we never have to remember that, isn't it? So your education is like this. If you do learn like that way, it makes your life more easier, make it simpler. So what should be the answer? answer or whatsoever. I'm saying that. So why we are now discussing that thing? What do you think? What is a new thing which we are not looking into that?
What if the IP address is wrong?
Okay, see, IP address problem is that the job of IP address is that it just connects host to host. Now that job is done. Now I am entering in a new world of my own computer. Yeah, the world of applications. Now, so much, let's say the water is coming in a pipe from outside and there are 50 houses inside that. If that water doesn't know where to go, in which pipe number I have to go, then that would be a total wastage of that, and it doesn't know that how to act. So basically, what is the verb in that? What is the verb in this? Identify. So the whatsoever the network traffic is coming on the internet, whatsoever it's flowing over the wires, when it reaches at your computer, how it knows that okay, this packet is for to which computer, which app it is going. Is it going to Mozilla? It is going for Firefox. It is going for some Skype. It is going for Teams, because it is in the form of IP address, and with the data is there. Data gram is there. Total that packet of data is there. So how it knows that where and which part of that is going to which application. So that is actually our main question is about, where now the new character will be entered, that is known as transport layer. So the transport layer job is to find out the correct app or application, because now our data is just at our doorstep. Okay, let's say you ask someone, or take an example here. There are two different cities, Melbourne and Sydney, and there are some cousins. They live apart from each other. 12 brothers and sisters live in one house in Sydney, 12 in Melbourne. And almost everyone has their age group fellow as well. And they want to communicate with each other, to write a letter. So if every single person or a kid is doing the writing a letter separately, how many total different number of combinations would be there? 12 people from one side and 12 people from the other side. How many different number of 144? Yes. So it means that 144 number of combinations are possible if each kid number one to the other one, and with each and every one they are want to communicate. So there are 144 different number of letters you need to send.
So each person has, each person is able to talk to the other 12.
Yes. Yeah. Yeah, each person the other want to talk to other 12, and the second one 12, third one 12, fourth one 12. So when you do 12 times 12, 144. Okay? Clear? So now understand one thing. Now this is a huge amount of data transmitting between both two. Why not we are assigning one person from Sydney, from those kids, make a group leader, one from Melbourne, and assign them. You should take the letters of everyone together, and because by 144 number of data or letter sending, it's a huge postage cost. We have to pay a postage cost separately to post office. Why not we should just one person should be the head of that, everyone should write their letter and just give to that one person, and that one person just put it in all together in one little bit bigger envelope put it there, and he will put their parcel as well. So it means that in one parcel now 12 letters are going on. Okay, and similar way,
That bigger parcel is the idea.
just I'm coming to that point. Hold on. Just listen the story and then we come there. So that 12 from that one, it means that one big parcel is having 12 letters from this side, and now so we reduced to two only from 144. Okay. Now remember that like those homes are like the IP addresses, but the people who are managing that thing are the job of a transport layer. What they are doing is they are, once they receive the letter of that box, because on the both hand they have the job now, when that received, so that same person is doing two jobs. One job of first collecting all, putting together in one, sending. When receiving from the other end, opening it and finding out which one is for which one. This is for Bob, this is for Peter, this is for Ali, this is for Muhammad. So in that way it is putting it separately and then giving to each of one in that house. Make sense? So in that way, the from the outside world, it looks like that a single packet of data is coming. But inside that, when it reaches to your home, then you are opening it to send it to the right destination, to the right app. So those kids are the applications, you can say now. Those 12 different applications are there. They have their own data, and the TCP transport layers is that boy who is the managing director of holding that all, distributing and collecting the letters. Make sense? So this is how, and also we need to check that whenever it is reaches, it is reaching without any errors. So that's another thing on the network traffic it has to see. So up till now we have seen that with those things. Hmm?
Thinking badly.
On backside, do you feel that? Like not last week. Is it only for this week?
Not only in this class, before starting this class.
Do you want to change the class then? Okay, just finish this slide and then we change the class. Okay. So networking levels of addressing. So we have done data link, network, address local devices by using MAC. Okay. Network by using IP addresses, and transport layer is now we are with the transport layer. They have their own characters, port addresses. What? Port addresses. That's something new which is under the umbrella of transport layer. Port addresses are similar thing like that. For example, there is a house, and that house there is only one address. But if there is a building where there is a 50 apartments, that has one address, but inside that apartment numbers are different. So port number is a apartment number, because you know the IP address but you don't know the port number. So based on port number, we are actually trying to find out our application. So it means that port number now comes to play its part to assign to a application. So every application works on some port number. By having the address of that port number, we know that, oh, this data is for this app, this data is for this app, by using port number. So well-known ports are used for server applications, other ports are used for client sessions. And we will see now how transport layer works with the port number. So this is a new thing for today. So whenever in future you have anything when we are discussing about a thing related to a port number or a TCP, something like that, transport. So it means that we are on layer of transport layer. Port number never be on data link or on a network layer. Okay. We can change the room then. Okay, so now moving to the next slide, which is about protocol data units at each layer. So remember one thing, the data which we are talking about from the very first week, that is the same data, but on every different layer, it acts differently. Okay, that acts differently. For example, taking example of a water. Water, when it is in -5 degree, how it looks like? Water. When in the form of a ice. When it is in 10 degrees, 15 degree, then 20 degree, then then what is its form? Liquid. When it's 100 degrees Celsius, then it is evaporation in the form of fumes. So same thing, but due to change in the condition, but the water is same. Similarly, your data is same, but at different layer, they have different names and there are different jobs. Make sense? So network layer, it is in the form of IP datagram. Data link layer, it's in the form of frame. Transport layer, it is in the form of TCP segment with a packet, or UDP datagram, either in both ways. Either TCP segment or a UDP segment. We will discuss about this one today. And when it is in physical layer, then it's form of a bits, binary data in the form of bits. Okay. So whenever in the future you have anyone with the discussion, someone is explaining this much number of frames of data is coming, so suddenly your mind tell you that he is definitely talking about on a data link layer. If someone says about the data is transmitted in the form of bits, then it means he is talking about in the form on a physical layer. If he is saying about with respect to IP datagrams, then on network layer. Whenever someone is talking about TCP or UDP words, then mean it is on a transport layer. So why do we need the transport layer now? As I mentioned before in that question, in the start, what was that question is like, when the data is reached at your doorstep, from that doorstep to taking inside the house, which persons to give which data, that's the job of a transport layer is, and that is done by port number. So we do multiple apps together concurrently, mean at the same time we have open 100 of different browsers, pages, email options, Google, Hotmail, Outlook, streaming videos are opening on different tabs, so they are concurrent parallelly. So the job of the transport layer is to ensure that each application has access to network. This is called multiplexing. Multiplexing, in a simple way, we can say that single pipe of data is coming. You put a mux like that which has multiple connections. One connection to 4, one to 8, or depends on how many number of ports you have, how many different apps you have want to, because we know that data is coming as one thing, but as soon as it enters the house, it has to see which apartment number or port number I have to go. Okay, depend upon the app. You should come here. Why you are sitting so far? Come here. When you are sitting more nearer, it's easy to focus. So each application can be distinguished from other applications that are running on the computer. So in that way, in the same computer, we know that different app is working on different port number, and by that we know that whatsoever the data is coming, where it has to go. And in case there might be a requirement of an application that arrives without errors, but this is not always the case. So sometime if there is a data arrives with having some like without errors, and there is something requirement of that. That's also the transport layer is actually uh, doing that job to ensure that it is going to the right app, not to the, like if the data is coming for Microsoft Mozilla and maybe it's going to some other app, so that would be a wrong thing. So what we cover in the transport layers, mainly five main things, but if we see there are mainly three things. First of all, segment and reassembly, individual identification of application, which is a port number. Third is UDP, TCP, then TCP connections and flow control. So if I see from here, so these three things are the same thing almost. So mainly three things: segmentation and reassembly, individual identification of applications, and TCP UDP, you can say. That's the main job of a transport layer is, and we will see one by one each of them in our today's session. First of all, with the segmentation and reassembly. Okay, can you please read this slide a bit loud?
Applications often send large streams of data for delivery, example, web page images, file transfer. The transport layer breaks up large chunks of data into manageable size segments so that network layer routers are able to handle them. So multiple applications can each get access to network. This is called multiplexing. At the destination, the segmented data must be reassembled by the transport layer back into the format sent by the sending application. This is called reassembly. Reassembly may also involve reordering in cases where packets were delivered out of order.
So you can see that there are a few important things. First of all, the data is in a large form of stream of data. It's going like a water. We need to make it in form of small buckets, chunks, to send it over the network. Otherwise, routers are not able to handle that huge amount of data. So we made it in small packets and then send it over the network. And when we send it over the network, of course, when it is going from here to here, it's many to less. When coming inside, it's less to many, because here it's one connection to many. When it's going from here to here, so many connections to only one. So the job of segmentation is that to put it in these small segments and sending over the network, and then reassemble it when it is received on the receiving end. And this whole process is done so that we are easily able to send our data, because if we are not sending in the packets, then we are not our routers are not able to handle them with the same amount of data. And also it is also good that if we are using multiple apps, so every application will get a data, so they have a share of each. Let's say you are at the same time using Skype, Mozilla, Outlook, Teams. So everyone have a chunk of data coming on in a turn. Rather, like one is coming and other are just waiting. So, but they know that where to go by using the port number. The next thing is identification of applications. How once it is reached at doorstep, how it knows that which application to identify and where to go. Can you read that one?
Users computer normally run multiple network applications
Concurrently.
concurrently. For instance, a browser and email client and a Skype. The transport layer allocates each client application a port number is
Distinguish.
from other network application running on that computer. Server domains running on network servers are also allocated port numbers. The combination of IP address and port number therefore allows client applications to specify the particular server domain.
Daemon. This is not daemon. Yeah,
It
demo.
also allows server daemons to distinguish between different applications and different sessions. Example, different browser tabs running on a client computer. In summary, each host is identified by its IP address. Each client each client application on that host is identified by a unique port number.
Yeah, the combination of host
The
IP.
combination of host IP address and associated port number is called a socket.
Yeah, so what we have seen here is, as we already discussed, multiple apps are running over the network. So what we are doing with the transport layer is it actually allocate every app a port number from where the computer or the system knows that to distinguish it where to send that data. So the server daemons, we'll discuss more in detail about that, but here their main job is to see on the network servers to which port is allocated to which IP address, which app. So IP addresses and port numbers. So there are two main things now. They are together. So we know that for that address, one IP address, but port number would be different for different applications. And also they are running on different tabs. So that's actually, we need to see that if we see the summary of this, every host, every computer has IP address, and every client application has IP address plus port number. But if we divide separately again, each computer has IP address, and with each computer, every application has its port number. Okay? So when we have two things together, port plus IP address, that is known as socket. The socket definition is, it is a combination of IP address and port number. So whenever someone is talking about a socket, it means that he is talking on a level of transport layer. Make sense? So remember that, again, just to recap, in data link, it was hop to hop, network, host to host, transport, like with the app to app, within the app to app, like distinguishing the app with the sockets. Because with the help of a socket, we are able to distinguish the apps. So basically, see, with the when we are talking about hop to hop, with the port to port, host to host, it means that with the hop to hop, we are playing in a data link layer. When host to host, we are playing in a network layer. Okay. So when we reach on the network layer, on the host to host, like two end computers, data is on their doorstep is reached. Once we enter into that home, then actually TCP, that transport layer comes to play its part. Okay, so transport layer's job is different from data link and networking. For example, data link job was to see the local network. Network layer job was to see the network of overall wider network between routers to routers. Okay, from the host to host routers networks. Whereas transport layer job is to see the network of your own computer inside that. There is a world of that inside your own computer. There is a world of apps, and looking that every app has their port numbers. With that port number, and of course you have the IP address on your computer, we know that that is whole thing is known as a socket. Okay. So this is an example here. Each IP address is associated with 65,536. This is 64 MB number of ports, and this is a way how to write it, putting a colon sign and then writing the port number. So this complete thing is known as now what? Socket. So when I say a word socket in the future, you know that it should have two things in that. One is IP address and second is port number. And here we can see a lot of different examples. And for each end of a transport layer, there is a UDP or TCP connection. We will see what is that about in next few slides. So we can see the active sockets on Windows. on our computer, because you can see that for to see the sockets on our Windows, there is a app or a command netstat, we can use it. So you can see here after colon, this is a port number, this is a port number, this is port numbers, and you can see these are different type of apps. Firefox is working on port number 51104, Outlook 50994, and then there is another 54 application, we need a different port number. So every single app with a different browser, maybe you have Mozilla with 10 different tabs, so every need a separate port number. It is something like that, you need a water of connection of water, and you need a pipe. Without pipe you can't get a water. So it means that if the same app has some port number, maybe when you need to open another app of same app, like for example, you already open the Mozilla one app and then you open another browser with the Mozilla again. So you need another port number again. So they can't duplicate it. Otherwise, how it will recognize where to go? Okay. So these are some standards. Port number 0 to 1, 0 to 3 are reserved for server daemons, and from 1024 ports are also known as well-known ports. These 1024 are, sorry. So these 1024 are well-known ports, and apart from that, from 1024 onward, they are dynamically we can use them. We can see in a few slides next. So here you can see that for FTP data, for FTP control, SSH, DNS, HTTP, HTTPS, these are their confirmed port numbers. POP2, POP3, SQL, DHCP clients, SMTP. So these are already assigned to them. They always work on those port numbers. Okay. Then user application port numbers. So those some of the user application port numbers are above than 1023. So for example, we have each application and each different tab session of a user, which I explained you, like a Firefox. So each have a different source port number. Okay. It's not possible that they have same port number. Still, we know that for maybe HTTP, we need this port number. But of course, with the Mozilla, we have seen in that example as well, port number one updating, because we need every one different ones. So this allows server application to uniquely identify different applications and even different sessions. Because for example, one session you started on a Mozilla with different time duration, and then you open new tab with the different time session. So they are on a different session, but same app, but they have a different port numbers. So server domains actually use specific port numbers. User applications know how to address requests to server applications. So basically, the server daemons is a main server who is actually doing that job for us to differentiate it. Like, okay, this session is created for this person, this port number with this address, and that is actually trying to figure out that whole thing for us. So both source and destination can uniquely identify each other, how that they are going on. Okay. So now we need to one thing, remember that discussing about the communication between source and destination on a network layer, it is host to host. When we are talking on a transport layer, it means that logically the sender, the destination computer, and the computer who is sending, both are logically connected on the app level as well. It's like the same way with the example of those kids. For example, those kids are logically connected with each other. When the parcel is coming on in one packet, when they open it, they don't know what is going on in between. Like the postman is coming that parcel to take to them. They only know that they are on their doorstep, they are getting only that one which they need. So for them, it looks like that you are directly communicating to that person who is sitting wherever it is, isn't it? When any parcel comes to your home, you are actually logically communicated with your sender. You don't know how many different steps it has step into that, but for you it is a very simple straightforward step. So that's known as a simple logical communication between two devices. Okay. So now coming towards the next thing, transport layer services is UDP. So as we mentioned, there are two different ports of that, UDP and TCP. UDP first, that is known as user datagram protocol, that provides basic transport services for network applications. This is their format, header format. This is a source port, destination port, the length of the packet, and the header and data checksum. I will explain a bit on that, but once I will explain the TCP, the UDP will make more sense to you as well. So first of all, we know that they have the information of that UDP header, which includes their source and destination port number, length of the UDP header, and a checksum. So in UDP communication, no checking is done to ensure packet arrives safely. For example, if you are sending a packet on a UDP, it never gives you the feedback or acknowledge that the parcel is received. You send it, you don't know it is. It's like that you sending a parcel without tracking. You send the parcel, but you don't know maybe it reaches or not. So mainly UDP packet is used for video, audio, or the huge amount of data streaming. Okay, and this is UDP is a stateless protocol, and we will see what is a stateless protocol now is. Okay, can you read that? Right.
The next protocol is a communication protocol that treats each request as an independent transaction that is unrelated to a previous request. Those protocols consist of independent peers of requests and responses. Because each transmission is a totally independent event, a statement like saying the next 10 bits of data has no meaning in stateless protocol because there is no concept of state or retrieve. This also means that UDP request must be 100% specific as to what they want. They want the destination to do. For instance, UDP request as part of a file transfer will be specified within the request. In the request, there is a specific location within the destination file where the packet's data must be placed. Example, bytes 204 to 276, and all the details of the file, such as the file name, file 123.php, and absolute path, home, user, and byte.
So what it is stateless protocol is doing is, without knowing the history of anything, you just send the packet without any request or receiving anything, without any relationship. You are sending something. So that is known as a stateless. You don't know the state of your receiver or sender before that. Whatsoever the packet comes, you just send it. And then once you send it, it is their request. You don't know what will come, what will go. That's independent of that. And for example, if you take the example here, let's say we are going to send a packet, we're going to file a transfer, the byte number 204 to 276 from this file to this path. What it will do by using a UDP request, it will just send those packets, but we don't know is it received or not. Okay. Now we come to the next one, which is TCP. And once we finish TCP, you will definitely understand what was UDP then. Because UDP, I know that still you have some questions in your mind. So with the TCP, TCP has this format header, which has sequence number, acknowledgement number, flags, window size, and you can see that how to read this header. You can see that this is bit number start from 0 and going up till 31. So how many total bits? 32. Then starting from 32, going up till 63. Then 64, going like the same way, and it's keep moving on. So this is their overall sequence number is there, acknowledgement number is there, different informations are there in that. So sequence number tracks the progress of data transfer. So it's a three-way handshake. We'll see what is three-way handshake. It is again smelling, but why it was not there before?
There is something in the AC.
We put the light on, that's why AC is on, or AC was off.
Like maybe internet starts running after some time and it starts. In that room also initially it was not there. After 1 hour.
Okay, close this recording and then we'll see. Then we have flag bits, and we'll see one by one each, all of them, what their main job is. And then we have a window size. So these are different parts of a TCP header. So TCP is a connection-oriented protocol, not like the way UDP is. In TCP, it first make the relationship and then start sending the data. So in that way, we are sure that wherever we are sending the data, the receiver knows it, and that receiver will send me the acknowledgement as well, that yes, I have received that. So that's the main difference between UDP and TCP is. TCP is more reliable and need three-way handshake, whereas UDP is unreliable, but it's a bit faster than TCP because it needs less number of protocols to move on. So TCP, what we are saying here is TCP must establish connection and send acknowledgement. It's a slower protocol than UDP. Whereas whenever we have a time critical issues, for example, in a video streaming, audio streaming, it's more preferable to use UDP because in video audio we know that it's a runtime thing, it's keep coming on. Whereas in the email, in the browsers, either it's there or not. But in the video, it's a keep going on thing. That's why in that one we can use UDP protocol. Whereas in the TCP timers is all about whenever any packet or anything, when it is you are sending, but it is not reached in that time limit, it always tell to the sender that, oh, this is not received in that time limit, it will send it back. So that's the job of the TCP timer, is detecting any packet which is lost. Okay, so if an acknowledgement has not been received within the time out, then the sender assume that packet is lost and it will resend it again. Okay, TCP flags, this is a computer's sound. TCP flag, every problem is coming today. So flag job is mainly in the form of boolean. Boolean mean either on and off. So there are number of flags: synchronization sequence number, acknowledgement segment, FIN, which is closing a connection, RST, about a connection due to an error, push, PSH, do not buffer data, instead send it immediately, or urgent, prioritize this packet. These are different flags which are we going to use in the TCP packet to do the communication. So these flags either one or one or on and off. If it's on, it means it is that flag is working and it is making its job. If not, then that's not working. We'll see some of the things in our examples and also in the lab as well. Sync actually indicates that it is sending the initial sequence number, which is ISN number, for use throughout the connection. And then let's see, we'll see examples and you will understand that. And also remember that this whole communication, when it's doing on, On the once three-way handshake is done, three-way handshake is like that. I will say, "Are you there?" You say, "Yes, I am there," and then I say, "Okay, I'm start communicating." So this is three-way handshake. Okay, and in similar way, once the data is start sending from one point to another point, when it is finished, then again you need to ensure that connection is closed. So whatsoever the connection is established, we need to finish it as well. So the three-way handshake does the following. To check it, the connection is established, establish an ISN between the client and server, establish a different ISN for communication in the opposite direction. This is something I will tell you in the example. Like for example, if I am sending the sequence number 1, the other computer send me 2. So in that way, I know that I sent 1, I received 2. So it means that he already, and it will be acknowledged. If I send 4, 5 will come. If 5 is not coming, it means that he has something else. So I have to send that one first from where I want to start the packet. Okay? So this is again the same thing which I explained. You can see, for example, step number 1, this is a three-way handshake. Always remember that it is always from the client. Client always goes to the shop. Client always go to the server. Server never comes to the client. So client is going to make a request. So that request is of the initial sequence number, which is sent by the client. Let's say sequence number is sent 5. The server responds with the acknowledgement 5 plus 1, 6. Both flags are set. The client acknowledgement, the server response, acknowledgement is equal to 6. That it means that they are ready to communicate. Okay. Again, this is client, this is server sending a packet 5, number 5. It will send it back 6, means that yes, 5 is received. Once it is received, that it will send the acknowledgement, yes, 6 is received. Okay, done. Three-way handshake is done. This is a three-way handshake, 1, 2, 3. And that way they know that now communication is established and we need to start. Again, in this example as well, same example is given, but I will explain it from here. In the Wireshark, we will have a look in the next slide. For example, acknowledgement number sent from a receiver is 55. From the receiver, not the sender. It means that sender is sending 54. Okay? If sender is sending 54, receiver sends 55. It means that 54 of the data bytes are already they are already received. So whatsoever it is, it will send the data after that. So therefore, all of the bytes of 54 of them prior to the acknowledgement number has been successfully received. So the next byte would be byte number 55. So in that way, two different aspects are cleared, or two different purposes are fulfilled. One is that it is acknowledged, one is that up till which number of byte it is data is sent. So we are not sending the data again, we are moving forward from them. Okay, let's say if we already sent the data of 55 bytes, why should I send it again? So if I know that my server is telling me that acknowledgement number is 55, so it means that as a client I will send 56 now, and the data from there onward. So this is again, let's say start the sequence number from 0 from the client, acknowledgement is 1. It means the byte number 1 is now indicating that the next byte in the queue is byte number 1, which is going to the server. Server is expecting byte number 1. Once byte number 1 is there, client straight away send 54 bytes in one packet, because this is our time now you are ready to send the packets. Once 54 bytes of packet sent together, server straight away send you the acknowledgement of 55. It means that by sending the acknowledgement of 55, client knows that 54 packets are received by the server. Okay, this type of exchange occurs in both directions using the two sequence number setup during the three-way handshake. So this is known as a TCP three-way handshake. So see this example in the Wireshark, which we'll do in the lab as well. In this example, there are total 10 different packets, 10 different segments, sorry. 10, 1 to 3 is for three-way handshake first, 4 to 6 exchange of data, 7 to 10 termination of the connection. So first of all, we are going to make a three-way handshake between 1 to 3. Okay, who is the first to initiate? Client. So this means that this is definitely a client. By having that knowledge that who is going to initiate the request or who is actually initiate the communication. So this is your client IP address. On port number 80, it is going to send a sequence number 0 with a flag sync. Sequence number 0. This is a IP address of a server. Port number 80, it is having two flags active because it's either 1 or 0. Remember that flags on and off. So whenever it's written, it's mean in the bracket it's on. So synchronization flag is on, acknowledgement flag is on, and why acknowledgement flag is on? It means that yes, it is working. So sequence number 0 is there, acknowledgement is what? 1, always +1 of the sequence. Got it? What? So see, what I explained is from the client, when sequence 0 is sent, acknowledgement is always 1. Sync, which we discussed in the flags. These are the flags: sync, fin, okay, which we see initially. These are the flag names. When they are there, it means that they are active. See, SYN flag means synchronize. Okay, synchronize the transmitter and receiver. Okay, next. This is again a client. See, client, server, client. Okay. On port number 80, it says acknowledged by the client. So it make it both 1. Okay, it means that now three-way handshake is done. See, 0, sequence number is sent, acknowledge 1. On the client side, client accepts that yes, I received your sequence number. Now sequence number is 1 and acknowledge 1 is mean three-way handshake is done. Okay. Now they are ready to send data between 4 to 6. So number 4 is client or server? No, see here, IP address. Client. Client is going to write any IP HTTP address on his browser, isn't it? We are going to enter any IP address or any URL address, any website. So let's say we put a website address of this one. So this is a HTTP request because now it's ready to send send data between the client and server because connection is already established. So it sent this one to the HTTP on that. From the server, it acknowledges that because you remember the sequence 1 is there, it acknowledges 390. This 390 means that 389 byte of data is transmitted in one go. Okay, because 390 is here. What is acknowledgement here? 1. 390 minus 1. So it means 389 amount of bytes are transmitted this in whole process. Okay? And this is again a server. Again, server is doing 2 to 3 jobs at the same time together from here in these three. This is a, see, once you as a person sending a request to a client or to a server, then these three jobs are done together at the same spot. One is sequence 1, it acknowledges that yes, 319 number of bytes of data, 389 number of bytes of data is received, and then once it is done, that data is transmitted to the client from the server. It will say okay. Okay, that once information is finished, then in the seventh one, sorry, 4 to 6 up till here. So this is done for the exchange of data. HTTP, TCP, and HTTP. This is client and server. Client is requesting HTTP packet, and data is sent by the server, and it says okay, it's done, and it says okay. Okay. Then the last one is coming again to finish this communication from 7 to 10. From 7 to 10. So what is happening from 7 to 10? Again, now from here, server is now, we know that all communication is done is okay. Then server is now activating a flag fin. FIN mean close the connection. And in that one, acknowledges flag will be there as well. So sequence number is 374 and acknowledge number is 390. So this is our acknowledgement number, which is coming there. Because remember that sequence number could be different because we don't know in how many different number of steps they are going back and forth. Because sequence numbers just tell you the how many number of going back and forth, but acknowledgements actually tells you that how much amount of bytes are transmitted. So 390 number of that. So here you can see now. So server is here, client. A client is telling that yes, acknowledged. Sequence number now 390, because remember that whatsoever is acknowledged here, that becomes the sequence of the next one. 390 and acknowledge that 375 number of with respect to that one is done. So it is keep changing. For one, let's say you can see it's a sequence for that. This become acknowledgement for that. This is acknowledgement for there. It becomes sequence for that. So this is how it is keep moving on. And then again finish an acknowledgement from the, so this is both from the client. These two different packets.
But it should start from the client, right? Why it has started with the server?
Because server knows that I already finished what you requested. That's why. Okay, that's good question. Because server once finished whatsoever the request made from the client is done by the server, it say okay. Once it say okay, then they start processing the information of how to close the connection. So in the same way, these two processes include acknowledgement with finishing of, because now this is finishing from the client as well. Here the finishing from the server. So finishing and that acknowledges, and at the end, this is again server here. So you can see that with the last communications, first server, if I say this is client server, first server, client, server. This is also three-way handshake. Okay. Again, when you do the lab today, it makes more sense to you, and when you see each and every and try to analyze that in Wireshark, okay, makes sense to you. So this is again explaining about that whole thing. HTML page is sent by the server to the browser, and then the finishing packet is sent The next thing is flow control. This is to see how to manage the flow control of data from fast senders. The window size field is the thing which actually implements that thing. There is in the header window size, which actually manage that how to flow the control of data. The value here specifies the maximum number of outstanding bytes a sender can send without receiving a corresponding acknowledgement. Receiver can slow or stop a sender from sending data by delaying acknowledgements. So if you think that too much data has come and you want to delay it, you will not going to send the acknowledgement. That way the next packet is not coming. This mechanism known as sliding windows flow control, where you are able to control the flow of the data in TCP. So here now is a summary of what we see in OSI layer model. We have 7, in TCP/IP model we have 5, and this is how now you should see the things. Like on application layer, you should talk about in the form of this: telnet, FTP, SMT, DNS. On host-to-host transport layer, we discuss about TCP or UDP. On internet layer, we discuss about ARP, IP addresses, host-to-host communication, and data link layer actually should come here as well, which is more on a network layer, sorry, which is Ethernet, hop-to-hop communication. So every layer has a different way of their words, characters. So you need to, that thing should be clear in your mind. If I am talking about a socket, it means that I'm talking about transport layer. If I'm talking about uh, Ethernet frame, then I'm talking about a data link layer. So that much things should be clear in your mind. That's what you have to do in the lab, learning more about Linux today, some commands, and then in Wireshark we will see again HTTP traffic, three-way handshake, and capture filters.
Commands are letters, maybe there is no function.
No, in the lab part you will see those all things. This is just explaining that how you need to do that. Then next week we'll do the physical layer. Okay. So that's all for our today's lesson. And of course, when you do the lab today, and yeah, in the lab also remember that in your lab when you open your lab sheets, you need to do a lab sheet, not problem sheet. Problem sheet is for yourself. Mainly lab sheet is one which you need to, there are some packets given there, put it in Wireshark and then analyze them, how they work. And second thing is that at the same time we want that you should be a good user of Linux, because Linux is much more used in networking. So if you know those things, so when you are going to finish your degrees, you know that okay, these are all skill sets, you already know that. That helps you to get a job. Because whenever you go to job, they straight away don't ask you the definitions. They straight away ask you, okay, how much skill set you have, what different software you have used, and then they will ask you those questions where we usually stuck. If you have done by yourself, you can answer. If you know, then your numbers will not help you there. Your experience, your working on the things by yourself will help you. Okay, that's all. Yeah, just close it then.